Well, hello y'all and welcome back to our next topic. We are still working on implicit differentiation. We'll just title this Day 2. So our goal today is to focus more on, free response questions such as horizontal tangent lines, vertical tangent lines. And let's attack our first problem here. So x squared y minus xy squared equals 2. This is just part A. Find all points, if any, at which the graph of the equation has a horizontal tangent line. Write an equation of each horizontal tangent line to the curve. So the key word here is horizontal tangent line. And that should give the whole problem away. So let's just think very elementary, very middle schoolish about the word horizontal tangent line. Let's go ahead and draw a horizontal line on our paper. And now think calculus. And when I say calculus, think slope. What do you know about the slope of this line? And again, you learned this back in middle school. What is the slope of a horizontal line? Well, hopefully you're saying the slope is equal to 0. And in fact, that gives the whole problem away. Slope just means set the derivative equal to 0. And that's how I'm going to attack this problem. I'm going to set the derivative equal to 0. Now, let's just continue thinking very elementary, and let's think of slope as rise over run. If I were to say slope is rise over run, and I have a slope of 0, which one is the 0, the rise or the run? Well, did you go up any, or did you just run side to side? I would say I didn't go up any, so that would be 0 over any number I wanted would get me a slope of 0. So in fact, when I get this fraction, I am just setting the numerator equal to 0. And look how simple that was to figure out. If you ever couldn't remember that, just go back and think basic. Alright, so like I said, we need to take this derivative and set it equal to 0. So by now, you should be pretty quick at taking this derivative, since we are reviewing. So pause it, see if your derivative matches mine, and then we'll set it equal to 0. Alright, so you can quickly see mine. I guess I'll run through first derivative of the second plus second derivative of the first minus, again, this is a personal preference. I always leave the coefficient, in this case it was a -1, out front of the brackets, take my derivative, and then distribute through afterwards. So hopefully you end up with this, which we all should. If you didn't, you could have the complete opposite, positive 2xy minus y squared, positive 2xy minus x squared, and that would be equivalent. At this point, we need to show, here we go, we're going to set that derivative equal to 0. And again, basically rise over run means set the numerator equal to 0. So I'm saying y squared minus 2xy equals 0. Basic elementary math here, I'm going to pull out a GCF of y minus 2x equals 0, a little nice teeing up. I get y equals 0 here, and y equals 2x. Now, unfortunately, I am nowhere near being done with this problem. I have to find equations of any horizontal lines if possible. Okay, so now I've got to take the values I found and first of all see if they're on the curve and then write my horizontal tangent lines. So let's start with this first value, y equals 0. I'm going to take that and substitute that into my equation here. Back into the original, of course. Everything goes into the original. I want to stress that. Everything goes into the original. So if I plug 0 into y, I basically get 0 minus 0 equals 2. Does that make any sense? And hopefully you're saying no, so this answer gets rejected. Now I've got to do the same thing with the y equals 2x because it's not an actual value. So I'm going to substitute that back into the original. So I've got x squared times 2x minus x times 2x squared equals 2. So what does that get me? 2x cubed minus, oops, I'm sorry, this squared should definitely be outside. That's 4x squared times x, so it'll be 4x cubed equals 2. It's negative 2x cubed equals 2. X cubed equals -1, therefore x equals -1. Now, once I have that, I need to take this x value that I got and substitute that back into the original. So I'm going to get -1 squared times y minus, that's going to be really plus y squared equals 2. So I've got, put these in order, y squared, that's going to be plus y minus 2 equals 0. Keep factoring. Y plus 2, y minus 1 equals 0, tee that up. y equals negative 2, and y equals 1. So I actually get 2 points. When x is negative 1, my y value can be negative 2, and when x is negative 1, my y value can be positive 1. Those both fall within there. Now, believe it or not, I still haven't answered the question. The question, let me review, said, write any horizontal tangent lines. Well, it happens at these points, but my horizontal tangent line, picture a horizontal line, has to say y equals something. So my lines would be y equals negative 2 and y equals 1. Make sure I'm grabbing the y values. All right, moving on to part B. Find all points, if any, at which the graph has a vertical tangent line. All right, so let's do the same thing. In case you forget, it's very simple. Just draw yourself a vertical line and ask yourself, what calculus could you have done in 6th grade? Well, you could have said the slope of this line. What is the slope of a vertical line? Well, again, hopefully you're saying it does not exist. And now, in rise over run matter, what part is 0? And again, it doesn't exist when the bottom is 0. So I'm going to take that derivative I had, and you'll recall, let me pull my derivative up, dy dx, so this is still from part A there. I think we had y squared minus 2xy, I believe, all over x squared minus 2xy. And I just want to set my denominator equal to 0, okay, because my slope is undefined. So x squared minus 2xy equals 0. And I'm going to do the same thing. Pull out a GCF, x, and you get your x minus 2y equals 0. Tee it up. I get x equals 0 and x equals 2y. Now let me recall the question here. Write an equation for each vertical line. So I do want it in terms of x. Now that I know these x values, I'm substituting them again back into the original. Everything's to the original. I'll get 0 minus 0 equals 2, which means nothing. This term gets rejected. I'm going to plug this one back in. So I'm going to get 2y squared times y minus 2y times y squared equals 2. 2y cubed minus 2y cubed. Oh, goodness gracious, that's 4y cubed minus 2y cubed equals 2. So that's 2y cubed equals 2, y cubed equals 1. Therefore, y equals 1. And once I know the y value, I need to go get the x value. And again, everything is back into the original. So if y is 1 and I plug that back into the original, I get x squared minus, so I'm just using this original up here, plugging y in as 1, minus x minus 2 equals 0. It's x minus 2 and x plus 1. I get x equals 2 and x equals negative 1. So remember, these points are actually 2, 1 and negative 1, 1. That is where I have vertical tangent lines. So if I were to write the equation of the vertical line, I need it to say x equals, so x equals 2 and x equals negative 1. All right, we're going to go ahead and do one more problem. It's going to have several parts to it, and hopefully we're on the same page here. So part A, find all points on the curve with x coordinate of 3. Basically, they're telling you the x value. All you need to do is plug it into the original and get the y value. There might be more than one because they're saying find all points. Pause it, try it on your own, see if we get the same thing. So hopefully you can follow my work. I replaced my x with 3, solve for y. I've got 2 y values, and I just want to state the points now because it does say find all points. When the x value is 3, my y value could be negative 5. And when the x value is 3, my y value could be 2. Part B, write the equation of the tangent line to the curves found in part A. Well, you actually have the point already. All you need is the slope, which of course in calculus means to take the derivative. So pause it, make sure you nail that derivative, and then we'll compare answers. So there you have my derivative. Remember, you could have the complete opposite. Now, my goal was to write the equation of each line I found in part A. And I found 2 because I had 2 points. I had 3, negative 5, and then I had 3, 2. So let's start with 3, negative 5. If that's my x and that's my y, all I need to do is plug them in to get my slope. So I'd say that's negative 5 minus 6 all over negative 3 plus 10. I get negative 11 over 7. So the equation for this first tangent line should be y plus 5 equals negative 11 sevenths times x minus 3. I'm going to do the exact same thing with my second point, which was 3, 2. I'm going to plug that into my slope. So that's 2 minus 6 all over negative 3 minus 4. Oh, does that give me negative 4 over negative 7 or 4 sevenths? And then a quick tangent line. Y minus 2 equals 4 sevenths times x minus 3. And remember, don't waste your time cleaning it up. We're good to go there. All right, next part. Find all points on that same curve, so this is part C, where the tangent line to the curve has a slope of 4 sevenths. And the whole thing is given away here. They're telling you the slope is 4 sevenths. So all I'm going to do is set that derivative I have equal to 4 sevenths. So once I've set them equal, just a quick cross multiply. So that gives me 14x minus 7y equals 8y plus 4x. You can solve for x or y. I'm just going to clean it up and see what turns out to be easiest. If I subtract the 4x over, that gives me 10x. If I add the 7y, that gets me 15y. Guess it doesn't really matter at this point. I'm going to say x equals 15y over 10, or x equals 3/2 y. All right, now this isn't an actual value, so I have to take this, and guess where you have to plug it back into? The same place every time. You are plugging it back into the original. So my original was given there. I'm going to replace my x with 3/2 y. Keep cleaning her up. When you square that fraction, just top bottom. So I've got 9/4 y squared minus 3/2 y squared plus y squared minus 1. I'm not a fan of fractions, so I just carefully look at my denominators, and I'm going to kill the fraction by multiplying every term by 4. And just if you do that, make sure you do it to every term. So I get 9y squared, it's 12 over 2, so minus 6y squared equals 4y squared minus 4. 9y minus 6y squared, that's 3y squared. I'm going to bring my 4y squared over, so that's negative y squared equals negative 4. Y squared equals positive 4. Y equals the most forgotten part, plus and minus 2. So these are my y values. I've got two y values. So I know my points are something plus 2 and something minus 2. All I need is the x value. And I think I had a nice simple equation for x. Remember, x is equal to 3/2 y. So if I keep that in mind, if x equals 3/2 y, and I plug in positive 2, x equals 3/2 times positive 2, that gets me 3. And if I plug in negative 2, that gets me negative 3. So I've got two values. Well, there you have it. Hopefully that covers most of our questions, and we'll see you in class tomorrow. Have a great night.